question 3, pretty big one here, involving a differential equation and then an exponential model. So, a circular ornamental garden pond of radius 2 meters has weed starting to grow and cover its surface. As the weed grows, it covers an area of A square meters. A simple model assumes that the weed grows so that the rate of increase of the area is proportional to A. So, as it covers more area, the rate at which it grows increases. We want to show that the area covered by the weed can be modelled by A equals BE to the KT, where B and K are constants and T is the time in days after the weed was first noticed. Okay, so the key to being able to do this is that we are told the rate at which the area increases is proportional to A. So the rate at which A increases is dA by dt. That is the rate of change of A over time. Now we know that that is proportional to the area. So first of all we should say that is proportional to the area. Now in terms of a formula we can say that dA by dt is equal to some constant k times A. Now what we're going to do here is split the derivative and rearrange so that we got everything to do with A on the left and everything else on the right. So if we multiply through by dt and divide through by A, then we get dA over A is equal to k dt. Now we can integrate on both sides. So the integral of dA over A is the integral of 1 over A with respect to A. So that's going to give us log A is equal to kt. Now we have to remember the constant C. Okay, now then we want to turn log A into A. So we now exponentiate both sides. So we get A is e to the power kt plus c. Now on the right, we can say that that is e to the kt times e to the c. Now e to the c is just a constant. So let B equal e to the c, and then A is indeed B e to the k t. Cool. Okay, part B tells us when the weed was first noticed, it covered an area of 0.25 meters squared. 20 days later, it covered an area of 0.5 meters squared. B part 1 wants us to find the value of b. So when the read was first noticed, t is equal to 0. So when t is equal to 0, a was 0.25. So we get 0.25 is equal to b, e to the 0. E to the power 0 is 1, therefore b is 0.25. Okay, b part 2 is slightly trickier, so we want to show that the model can be written in the form a equals 2 to the power t over 20 minus 2. So, there's one other bit of information that we can use here, and that is that we know when t is equal to 20, a is equal to 0.5. So what we're going to do is find the value of k. So, we know then 0.5 is equal to 0.25 e to the 20k. Now if we divide by 0.25, we get 2. So that's good, because we definitely want a 2. That is equal to e to the 20k. Now if we take logarithms, log 2 is equal to 20k. Therefore, k is equal to 1/20th of log 2. So, at this point, we can write a as 0.25 times e to the 1/20th log 2 times t. Okay, so what can we do with that? Well, that power 1/20th log 2 is all multiplying together. So we could use brackets to split that power and actually eliminate the e and the log. So we could say that a is equal to 0.25 times e to the log 2 to the 1/20th, or to the t over 20. Now, e to the log 2 is just 2. So, a is equal to 0.25 times 2 to the t over 20. So we're getting close. Now 0.25 as a fraction is 1/4. So we could try this as 1/4 times 2 to the t over 20. Now 1/4 is 2 to the minus 2. So this is 2 to the minus 2 times 2 to the t over 20. So finally, A is indeed 2 to the t over 20 minus 2. Cool. Okay, B part 3 wants us to work out how many days it will take for the weed to cover half the surface area. So the pond is a circle with radius 2. The area then is 4 pi, half the area then is 2 pi. So we want 2 to the power t over 20 minus 2 to equal 2 pi. Now we know that 2 to the power t over 20 minus 2 can be written as 1/4 times times 2 to the t over 20. So if we multiply both sides through by 4, we get 2 to the t over 20 is equal to 8 pi. If we take logs of both sides, we get t over 20 log 2 is equal to log 8 pi. Divide through by log 2, t over 20 is equal to log 8 pi over log 2. Finally, multiply through by 20, we get t is 20 log 8 pi over log of 2. Now if we go to 2 decimal places, you will get 93.03 days. Cool. Okay, then part C asks us to state one limitation of the model. So it's a classic situation. The model predicts that the weed will keep on growing and growing and growing forever. This cannot happen. The area of the pond is 4 pi. So the area covered by the weed can only get to 4 pi meters squared. So the model predicts the area covered by weed will increase without limitation but in reality A can only reach 4 pi. Cool. Okay, then for part D, we want to suggest one refinement that could improve the model. So, ideally, something to fix the problem that we mentioned above. So, some sort of limit put into the model, or we could talk about how the model is very simple and that we haven't really mentioned anything acting against the growth of the weed. So in the mark scheme they even mention that the fish might eat the weed. Now if that happens, obviously the surface area is going to decrease as the fish eat the weed. I would also say we can mention the model didn't take into account where in the pond the weed was starting to grow. So if it will start to grow in the centre, then it's going to spread out in every direction. But if the weed started to grow at the side, then it can only spread in a certain direction. It can't spread out over a 360-degree area. Or I think we could also say that as available surface area of the pond decreases, then the rate at which the weed will cover it will probably decrease too, because less weed will be growing into a smaller area. So anything like any of that and you should be cool.